Hi, everyone. In this video, I'm going to introduce you to linear regression using Stata. And basically, the idea in this demonstration is not to really go over all aspects of linear regression, but rather to show you a couple of ways in order to carry out linear regression using Stata. Um, and also to kind of begin demonstrating the structural equation modeling capabilities that are available in Stata. So it's not typical for folks when they run a linear regression to perform that analysis using structural equation modeling, but that's a very simple model to start out with. And I wanted to show you some of those features um, using a very simple model. So that's basically the idea that we're going to be operating from. Now, as you're looking at the interface that's opened up, I want to draw your attention to a few things before I begin with this demonstration. So first off, you'll see that at the very bottom here, there's a command line. And so down here, this is where you can type in various commands. You can use Stata syntax in order to carry out various analyses and so forth. And that's a very nice, quick, efficient way to carry out your analyses. And the syntax is very well documented. It's very easy to use oftentimes. Sometimes there's a little bit of a few tricks that you have to kind of keep in mind. But by and large, that command line is your friend. So if you want to run your analyses though, and you're not really wanting to use a lot of syntax or whatever, then one thing that you can use is the drop down menu system. So if you go over to statistics, you'll see that you have a number of different drop down menus. For instance, if you wanted to run a linear regression, you can just using standard least squares regression. If you go to right here, you've got linear models and related linear regression. You can actually run your regression analysis through that. If you want to use structural equation modeling, there's a graphical user interface. You can go down here to where it says structural equation modeling, model building and estimation. If you click on that, you'll see that you can actually draw out a model here and then run the model from that diagram that you create. So that's a nice thing to be aware of, and I'm going to be demonstrating that in this presentation. The other thing that I want to draw your attention to is if you go over here, you'll see it says new do file editor, this little button right here. If you click on this, you have a little system right here where you can type in commands and basically batch run those commands. And so the do file, basically if you have an understanding of the syntax for various analyses and functions and so forth in Stata, one thing that you can do is you can type in your syntax, save it to the do file, and then if you wanted to call it back up later and then rerun your analysis or use it, maybe using a different data set or making tweaks and so forth, then you can do that using the do files that you create. And in fact, most of the time, I actually don't bother with the command line, except if I'm using very simple syntax. Oftentimes what I'll do is I'll use the do file editor and save my work there. And then if I want to rerun the analysis or make tweaks to the analysis and so forth, I can make the modifications using syntax within this editor. Sometimes also what I might do is I might, create like a text file and then type the syntax in there, and then I might copy and paste that syntax into a do file. That works too. So I'm going to show you also how to use this do file editor in the context of this presentation. So the first the basic analysis that we're going to be working with is going to involve one that is presented in Chapter 3 of Whitaker and Schumacher's 2022 version of a beginner's guide to structural equation modeling. So the first thing that I want to draw your attention to is just the model itself. Basically, what we have for our regression model is one where we are predicting satisfaction as a function of age, severity, and anxiety. So you can see on your screen right here, basically the prediction equation that is given is basically fitted y, or the predicted scores on y for satisfaction, are a function of age, severity, and anxiety. In our equation right here, you'll see that we have the intercept plus the product of age and its associated partial regression slope plus the product of severity and its regression slope plus the product of anxiety and its associated partial regression slope. So this is the basic model that we're going to be running, and I'll just kind of refer you back to that chapter for a lot more of the details and so forth. But this is the model that we're going to be running using Stata. So I'm going to go back into our Stata right here. And the first thing that I'm going to do, actually, I'm going to get rid of that. And the first thing I'm going to do is go ahead and import our data. So I actually have the data stored in a CSV file. And by the way, you can actually store your data in a Stata data file. If you wanted to get your data from a Stata data file, all you'd need to do is to go to File, Open, and you'll see right here, this is my downloads folder, but I actually have a number of Stata files that are shown, and you'll see like this one right here. It says Stata data set under type, and that's a Stata data file. There are other data files as well. There's a do file that I've created for another example and so forth. So, but I actually have the data stored in a CSV file. So what I'm going to do is go to File, Import, and then I'm going to go down to, or actually I have the data stored in an Excel file. So I'm going to click on Excel spreadsheet right here. And the next thing I'm going to do is go to my location on my computer where this spreadsheet is located. So basically I'll click on Browse right here and to locate that file. So I actually have it under a folder on my computer on the desktop here. And this is the Excel file. So you'll see down at the bottom, it says to the right, it says Excel files, XLS, SX and XLS for different versions and so forth. But we're going to click on Open right here, this particular file. And the first thing to note too is as you're looking at this, it says import row as variable name, or first row as variable names. So the variable names are actually in the first row of my Excel file. So I'm going to be sure to click on import first row as variable names and then click on OK. And so now the data has been imported into Stata. And if I want to take a look at it, I can go over to this little button right here for the data editor, and you can see this is the actual raw data that we're going to be working with. You'll also notice too, as you're looking at this, that if you go look on the right over here, it's got the variable names and labels and so forth. So this is telling me obviously that we have these are we have our data imported into Stata. And by the way, if I wanted to save this data file as a Stata data file, it's actually quite easy to do. I can go to File, go down to Save As right here, and you'll notice that down at the bottom, it says Save As Type, and it's got Stata data, and it's a DTA file. So basically then, if I just click on, type in a name and then save it, it's very easy to do. So let's just do that real quick. I'll just type in Save As, and we'll just call this Satisfaction, and then click on Save right here. And so now I actually have the data saved as a Stata data file. Just to show you what I'm talking about, if I go back under my examples, you can see that now we have a Stata data set. So it's really easy to use. So the next thing I'm going to show you really quickly is just how to perform just a basic linear regression using OLS regression. A couple of options that you have available. One option is to go up to Statistics, click on Linear Models and Related, and click on Linear Regression. And for the dependent variable, I'm going to use satisfaction as my dependent variable. For my independent variables, I'll use age, severity, and anxiety right there. If I click on OK, then you can see that I get my output right here. And just kind of looking at it, you can see that we have our R-squared value right here, which is the 0.6854. The F-test is given right here. So you can see that the set of predictors are accounting for about 68.54% of the variation, and you can see that the overall model is statistically significant, or the predictors are accounting for significant variation in satisfaction. You also see that you got your ANOVA summary table information provided over here. And then in the bottom, you can see that we have the unstandardized partial regression coefficients. Here's our intercept for the regression model as well, along with the standard errors, the t values, and the p values. We even have 95% confidence intervals right here. Just so you know, if you wanted to obtain the standardized regression coefficients, you could easily do that as well. Just go back under linear regression, and under reporting, if you you can click on standardized beta coefficients right there and click on OK. And so now you'll see that in this in the output, instead of the confidence intervals that were given up here, you now have the standardized regression coefficients that are given right there. So that's just kind of a very quick and dirty overview of using the drop down menu. There's also various post estimation commands that you can use as well. Just to show you what I'm talking about, if you go under statistics, if you go down to the bottom, a lot of the main analyses have post estimation options that are available. So if I click on post estimation, you'll see I have various options that are available, such as diagnostic and analytic plots. I can generate predicted values and residuals and so forth. So you can go under a lot of this stuff right here and see, get some additional information. Just to show you what I'm talking about, if I click on residual versus fitted plot right here and click on OK, you can see that this is a plot of the unstandardized residuals against the fitted values on Y. So just kind of keep in mind that in Stata, a lot of the analyses, you have sort of the primary analyses, and then there's a lot of post estimation options. So like if you're used to something such as SPSS, where you can kind of go and click everything all at once and generate everything all at the same time, in Stata it's a little bit different. You have your primary commands and functions, and then you can run your analysis, and then there are post estimation commands or functions in order to carry out supplemental analyses and so forth. So just kind of keep that in mind if you're not used to using Stata. Just so you know too, if I wanted to use syntax, you'll notice that looking at our output, like when I ran this through the drop down menu the first time, you'll see that it actually gives me the syntax. So if you're trying to learn the syntax in Stata, the nice thing is that if you use some of these drop down menus to carry out your analyses, it will generate the syntax associated with them. So as you're looking at this, just kind of keep in mind that you'll see that there is a regress. That is the main function, followed by the names of our independent variables within our regression analysis. So we have satisfaction, age, severity, and anxiety. And just to kind of show you that, I can actually run the analysis very simply by going down to the command line. If I type in regress and then the names of my variables, so we'll type in satisfaction, age, severity, and anxiety, and then press enter, we get our output. The same goes for, this is where we had requested the standardized regression coefficients. The difference in this particular case right here was that we had our basic regression command followed by the name of our dependent variable. So keep in mind, that's the name of the dependent variable followed by the names of the independent variables. So sorry about the drawing there. Then you'll see that we have a comma. And then following that comma, we have various options. The only option that we had requested was beta, which is for the standardized regression coefficients. So keep in mind that the general command structure oftentimes is going to be the main portion of the analysis. You'll have a comma, and then following that, various options. So if I go down to command right here, I can type in regression, or I can type in regression or regress, then satisfaction, age, severity, anxiety, comma, and beta, and then hit enter. And you'll see that actually, I'm sorry about that, I should have used the regress command. So excuse me there. So satisfaction is the name of the dependent variable followed by the names of our independent variables, anxiety right there, comma, and then beta. and then hit enter. And so there you go. Now we have our basic regression information. You'll also see that when we generated that plot, this is actually the syntax for that plot. I can just type in RF or RVF plot in the command line and hit enter, and there you go. So the nice thing is that if you're kind of new to using Stata syntax and so forth, if you are running things through menus and such, the menus, the syntax will be generated. You can kind of learn a little bit about the syntax that way. The syntax is also very well documented on the web as well, and so we'll kind of get into some more of that as we go through the course. So at any rate, that's just kind of a general overview right there, just using least squares regression using Stata. Now let's say that I want to run my analysis using the structural equation modeling features. So one approach that I can use is the graphical user interface. So to do that, I can go to statistics and then go down to where it says SEM, structural equation modeling, and I can click on this little button right here for model building and estimation. So if I click on that, I now have basically an interface where I can draw out my model. So as you're looking at this, a lot of the features are very similar to what you have in with Amos, which is another common structural equation modeling program. So you'll notice that as we look at it, I'm just going to kind of highlight a few things. You'll notice that on the right, or excuse me, on the left over here, you've got, this is basically kind of a select button right here. So we're not really going to be working with that except to kind of turn off certain buttons and whatever. The box that you see right here, this is to draw manifest or observed variables. So if you go back and you look at our previous diagram right here, you'll see that I've drawn this out using various boxes. So basically a box in structural equation modeling, kind of parlance, if you will, the boxes are representing manifest variables or observed variables. So those are variables that you actually have data on. And so you'll see that so if we're using the graphical user interface, when we select the box, that's to draw in a manifest variable. You'll also see that we have arrows. We have single-headed arrows that represent directionality, basically the effect of one variable on another variable. And then double-headed arrows are used to indicate correlation or covariance between variables. So if we go back right here, you'll see that as we're looking at our interface, we can use the boxes right here to draw manifest variables. We have single-headed arrows right here to indicate kind of a directional effect of one variable on another variable. And then we also have the double-headed arrow right here to indicate correlation or covariance. Another thing too in structural equation modeling is that when you have ovals, or basically circles or ovals, those are used to denote latent variables, and they're also used to denote measurement error. So this right here, although we're not going to explicitly draw out anything using this right now, that's basically what the circles or ovals are utilized for. So let's go ahead and draw out our model in the graphical user interface. So what I'm going to do is I'm going to click on this little button right here to select the boxes. So you can see right here, I can just, it's a little hard to see, but basically if you click over here, you can see that I'm drawing out these different boxes. So we had 3 predictor variables and we had our dependent variable right here. Now, what I'll do is if I want to select off of that, then I'm going to click on the little arrow right here. And now you can see that I've selected off. Otherwise, if I just kind of leave it selected, then I can inadvertently draw out things like that. And I don't want to do that. So I'm going to select off and I can delete these two. I can just highlight and click and then select delete to get rid of those boxes right there. Next, I'm going to draw in the path. So I'm going to click the button for add path and then highlight the first variable. You can see it kind of turns green right here, and then draw to this box right here. Okay, and now you'll notice that when I draw that out, you'll notice that now this little error appears. So that's reflecting prediction error. So so that's kind of drawn in automatically. I don't need to draw that in explicitly. It's going to go ahead and take care of that. So next, I'm going to keep selection or drawing my arrows in, my single-headed arrows that way right there. Now at this point, I'm going to deselect that option. And so now I've got my 3 arrows drawn in. And then I can also then select add covariance. So I'm going to click that little button right there. And you can just see that I'm going to draw really, I tend, when I have the predictors and so forth on the left side, I'll tend to just draw up from one to the other. So I'm just going to draw up right there. And you can see that now they're adding in double-headed arrows. And I'll deselect right there. And so now we've got that. You can also see that we can click on the boxes and so forth and move things around in this kind of way right here. If I wanted to, kind of straighten things up a bit like that, I can just kind of move that around. If I want to move the arrows, I can click on the arrow, and it may be hard to see, but you can move things around as well. So you can kind of clean things up as needed using this graphical user interface. I'll just kind of draw that down right there. Now, the other thing too is that now I need to add the variables into these boxes, right? And one thing that I do want to point out is that in structural equation modeling, we don't use the terms independent and dependent variables like we use in the context of standard linear regression or analysis of variance. Basically, the variables are sort of broken out into 2 general classes, but they're referred to as endogenous and exogenous variables. So just so you know, an endogenous variable is a variable that has arrows pointing to it from other variables. So basically, it's a variable that is predicted by or with variance accounted for by other variables within the model. A variable that does not have arrows pointing to it from other variables in the model, those are referred to as exogenous. And so the reason why this matters is that, right now in the context of linear regression, the predictors in our model that we're drawing out right now, those are basically exogenous because as you're looking at them, we don't have any arrows pointing to them. We do have covariances that are specified among them, but we don't have anything, kind of upstream that's pointing to those. So these variables are referred to as exogenous. The outcome variable that we have right here, this variable right here, this is an endogenous variable. Now, if we had a more complex model that we were drawing, let's say, for instance, that I was going to draw out, let's say instead of having just a multiple regression, let's say that I was going to add in another outcome variable, and where this outcome is maybe an outcome of these 2 variables right here. In this particular case, we would actually have 2 endogenous variables within our model. The first endogenous variable would be this one right here, and the second one would be this one right here. So as we get into more complex models where you can have multiple variables that are serving as outcomes of other variables sort of upstream, if you will, those would all be endogenous variables. And so that's where you get into, like in this case right here, an example where you might have a model where you're testing for mediation. So just kind of keep in mind the difference between endogenous and exogenous variables in the context of linear regression. Like I said, in the context of SEM, we don't typically refer to independent variables and dependent variables like you might be used to. So what I'm going to do is get rid of this. So I'm going to go ahead and highlight. I'm going to actually click my little arrow and then highlight this and delete it so I can get rid of it. And now we're going to go ahead and add in our variables themselves. So if I click on a given box, you'll see there's a little drop down right here, and I can select the one of those variables. So I'm going to go ahead and select, I believe in our model we had age, severity, and anxiety. So I'm going to go ahead and select age right here. I can select the next box right here and click on severity, and then the next one right here and click on anxiety. And then for my endogenous variable, I'll go ahead and select satisfaction right there. And so now, we can just basically run our model. So if I click on estimation right here and click on estimate, you'll see that we have maximum likelihood estimation. That's the default. If there are any missing values, basically it's going to utilize listwise deletion. If I wanted to account for the missing values using something like full information maximum likelihood, then I could click on maximum likelihood with missing values, and that will kind of take care of that particular option. But we're going to stick with just the basic maximum likelihood that we have right here. Under this little tab right here, this is actually available if we were running this using the drop down in and using just basically a standard linear regression. There's several options here, maybe some options that maybe are not through the other the other menu I was telling you about. But you'll see we have default standard errors. We're just going to leave that there, but you'll see that there's options for robust standard errors, clustered robust. You'll see there's bootstrap and so forth. So those are some options that are available. Under reporting, you'll see that you can also request standardized coefficients and values, but I'm going to leave this off right now and just go ahead and click on OK. So click on OK, and so now the model has been run. You'll see that what's appearing in our figure right here, these are unstandardized coefficients because I didn't request anything in standardized form. If I click on the age variable right here on the right, you'll see the details for the different estimates. So you'll see that on the right over here, by selecting age, you'll see that I get, the mean for that variable. We've got the standard deviation. We've got, there's the variance, the standardized variance. Obviously, that's going to be a 1 right there. But that's just some information right there. If you click on a given path, like right here, you'll see that to the right, you'll see the coefficient. And so you've got the regression slope of negative 1.153. And so you can see it's basically rounded off at a negative 1.2 right here. You've got a z value and a p value that's given along with a confidence interval. And the standardized coefficient right here, it would be a negative 0.657 and so forth. Just kind of keep in mind that the z that you have right here, the test, in the context of linear least squares regression, the test statistic is going to be a t-value. In the context of SEM, where we're using maximum likelihood estimation, the test statistic is a z-value. And part of that really, a large part of that has to do with that we're using a large sample technique in order to analyze our data. And so, if you go back and you think about the t-distribution, it's going to be most applicable when you have basically a small sample size that you're working with. But as your sample size increases to positive infinity, the t-distribution will essentially converge onto the z-distribution. So in a large sample, there's not really going to be a need to use the t values. You're going to be using z values. So just kind of keep in mind that when you're using SEM, generally speaking, it's a large sample technique, and so that's the reason why you have the z values printed out instead of t values. So at any rate, if we look over on the left side of the, basically our double-headed arrows, you can see that we have covariances. So this is just a covariance between age and severity right here. So that covariance value is given right here along with the z value and p value for significance tests. And then you can see also with the standardized covariance over here, this is just basically going to be the correlation between those two variables and so forth. So if I wanted to take a look, let's just say I request, if I go under set estimation, and we'll just go ahead and clear the estimates right here, go under estimate, and under reporting, if I click on display standardized coefficients and values and then click on OK, well, now you can see that we've got everything given in basically treating the variables as all being standardized. So you can see right there, there's the correlation between our two variables. And so, this is the same value that we had just discussed a couple of minutes ago or a few seconds ago. You can also see that these are the standardized regression coefficients that are given. And you can also see that we have our, significance test for all of those as well. So those are just kind of, keep in mind that these are a couple of options that you have available looking at the diagram itself. Now, if I'm going to shrink this window a bit, and let's just go back and if we go into the main menu right here, you can see these are the analyses that these are the results of our analyses that we had just run. So in fact, if I go back, I'll just show it again, show it in real time. I'm going to go back under estimation and we'll click on estimate. I'm going to get rid of the standardized coefficients and just leave everything else as is. And if I click on OK, you'll see that we generate, in this particular case, we've generated our unstandardized regression coefficients and so forth. So you'll see, looking at our output, kind of scroll up just a bit, you'll notice that in terms of the syntax, this is the actual syntax that is generated by virtue of our model specification using the graphical user interface. So you'll notice that we have SEM, and inside we have a parenthesis here. We have age with an arrow. That's just a hyphen followed by a greater than sign, pointing to satisfaction. And then we have in parenthesis, then we have severity pointing to satisfaction, and then we have anxiety pointing to satisfaction. You'll see that we also have an option, options that are given, just basically typing in a comma, and then we have COV for covariance, and then you'll see that we have severity, asterisk age, then anxiety, asterisk age. So it kind of carries over down here. That you see right there, and then we have anxiety, asterisk severity, and then last it says no caps latent. So just so you know, when you're using the syntax in order to draw out your run your analyses and so forth, my general recommendation is just to go ahead and always use no caps latent. So that's kind of generated by default. As we scroll down, you can see that we have the log likelihoods for a couple of iterations for the model that were which you see right here. So this is the log likelihood for the final iteration. The log likelihood is just basically an indicator of fit of the models. It's not particularly useful in and of itself, but the log likelihood is utilized in various fit measures that we'll be talking about later on in this course. As we scroll down, you'll see a number of observations. We only had 24 observations in our data set. This is woefully inadequate for running SEM, but this is just to kind of, this was a very simple data set that we're working with. And so this is just to kind of show you how things look. So at any rate, as we're looking at our output, you'll see that we've got coefficients. These are now the unstandardized regression coefficients. We have the standard errors associated with our coefficients, z values, and then the p values are given along with confidence intervals. So you'll see in the structural portion of the model, we have age as a predictor of satisfaction, severity as a predictor of satisfaction, and anxiety as a predictor of satisfaction. So these are the unstandardized partial regression coefficients along with their significance levels. So you can see that age, severity, and anxiety, all three of those are negative predictors within the model. Of those predictors, we had age and anxiety. Both of these are significant predictors. So severity was not a significant predictor within the model. So basically what this is telling me is that individuals who are older and who have greater levels of anxiety express lower levels of satisfaction. You'll also see in our output, we have the means for our age, severity, and anxiety variables right here. So there they are. You'll also notice that the intercept for the model is the 156.6224. And the intercept is just basically in our model, it's just basically the mean on satisfaction adjusted for the predictors within the model. So that's why you don't see an estimate for the mean for satisfaction in this portion right here. So this is the like I said, that's it, the intercept for our model. You'll also see that we have variance estimates. So the variance for estimate for the residuals for satisfaction. The residuals are just basically prediction errors. And so the variance of the prediction errors for the model is 84.777. Then we also have variance estimates for each of our exogenous variables within our model. So for age, severity, and anxiety. And then we have the covariances between our variables. So you see it says cov, age, severity. There's the covariance, age and anxiety, and severity and anxiety. So again, this is all in unstandardized, or this is basically assuming unstandardized variables. If we wanted to rerun our analysis, again, just requesting standardized estimates. If I click on estimate and go to reporting right here, we can click on display standardized coefficients and values, and then on OK. And so now as we're looking at our output, you can see that we have up here, it says standardized. And so these are the standardized coefficients, or the beta coefficients, if you will, along with standard errors and z values. And these values are, if you make the comparison with what we had before, you'll see that, this was our Z value for our Z test value, and the P value 0.593. If we go back up here, you'll see that those are exactly the same as what we had with the unstandardized solution. But nevertheless, these are basically the standardized regression coefficients that are given right there. We still have our means for our exogenous variables. This is the variance of the residuals. And down here, then these covariances, these are basically correlations among our exogenous variables. Now, if you want a little bit more detail regarding the model, like for instance, if you want the R-square value, well, we can use post-estimation commands as well. So if we go under statistics and go down to the bottom where it says post-estimation, you'll see that I'm going to click on specification, diagnostic, and goodness of fit analysis. And I'm going to click on overall goodness of fit. Excuse me, I'm going to click on equation level goodness of fit right there. And so these are just basically various post-estimation options that we can select. So you'll see that let me see if I can highlight this. Right here, it says estat. So if I was typing a command, I would start out with estat and then the option in terms of which function I want to use. So in this case right here, we're just using this little drop down. So I'm going to click on OK. And so now you'll see that in terms of the equation level goodness of fit, first off, there's my estat main command followed by the specific function or option right here. You can see it says EQGOF. So that's equation level goodness of fit. So in fact, if I go down to the command line and I type in estat EQGOF and enter, you'll see it's exactly the same. So as you're looking at this right here, you can see that we get our R-squared value for our model. So it's a 0.685 right there. You can also see this is for the overall model. It's going to be exactly the same, of course. And then you can see that we've got the this is basically the multiple correlation between the set of predictors or independent variables or exogenous variables in SEM terminology and our endogenous variable, which is satisfaction. So that's kind of just a general overview using the graphical user interface in order to generate just a very simple linear regression model. Now, if I wanted to run the analysis using syntax, just to kind of show you this, what I can do, and I'm instead of using the command line, I'm actually going to open up the do file editor. So I'm going to click on the little button. Sorry, just let me show you where that's at. So I'm going to click on this little button up here. This is where the do file editor would be located. So I'm going to click on that. And so now we have our do file editor that's opened up. So in the do file editor, like I said, you can use this to type out, create your models and run your models and so forth, but you can also save your work. And so you can go back and revisit it. You can, if you want to run your analysis using a different data set or whatever, it's a lot easier to do than just to simply draw things out using that graphical user interface. The graphical user interface is obviously very easy to use, but in much more complex models, using syntax will oftentimes make life a whole lot easier. So what I'm going to do is I'm going to go ahead and type in, I'm going to use the function. If you if you go back up here, and you can see our syntax for our SEM. Now it kind of goes over to the next line, so I can't copy this directly, but I could copy this and get rid of, you know, that little sign right there, which would throw things off. But just to show you, I could actually copy all of this and paste it into the do file editor right here. Now, if I try to run it this way, you'll see that I get an error. And the reason why is because it kind of wrapped around, and you'll see over here, you'll see there should be a Y on severity right here, and it should wrap around. And then you've got this little cursor that's showing up. So that's really the problem right there. But if I wanted to, I could clean this up. What I can do is I can actually get rid of the cursor. I'm just going to delete that cursor and bring that Y back over like that. And so now you can see it kind of shows up when I highlight all of this and click on run. Let's see if I can find my little run. Yeah, there it is right there. Execute selection in the do file. You can see that now my output shows up. There it is. So if you want to make life a little bit easier, though, so obviously you can draw out your model and you can save your syntax to the do file editor and run your analysis that way. Just to show you what's going on, though, and actually, if I want to make this a little bit simpler, you'll see that what it's done is it's basically generated a prediction from age to satisfaction, severity to satisfaction, and anxiety to satisfaction. That's three separate parts of the analysis, but I can actually simplify this. If I type in SEM, that's the main function for performing the SEM. Inside parenthesis, I can type in age, severity, and anxiety, followed by my little arrow, which is just the hyphen, followed by the greater than sign, then type in satisfaction right here. You can see that we can simplify things dramatically. Then I'll type in a comma, and then I will type in, I can type in COV, and then we'll type in severity, asterisk, age. So that's basically going to be generating the covariance between severity and age, then anxiety, asterisk, and age, which will give me that covariance, and then the covariance between anxiety, asterisk, and severity. And then outside the parenthesis right here, you can type in no caps, latent right there. Okay, so now if I highlight this and click on execute selection, do, there it is. So now we've got everything that we had before. If I wanted to add in the, incorporate standardized coefficients, I'll copy this and just show you the next line. I can just type in standardized right here and highlight and click on execute selection. And so now you can see that we get our standardized regression path coefficients right there. So there you go. Now, another thing to note too with your do file is that, you can see it seems to continue on, and it's a little bit tricky sometimes, especially as you're looking at this. You can see there's like a little line on the page right here. It's almost like, a notebook paper where you run into the margins over here on the right. And, let's say you want to wrap things around and you want to kind of keep things a little bit cleaner. Well, one thing that you can do in this case is to use a little break. So I'll show you what I'm talking about. So let's just say I type in SEM, age, severity, anxiety, with my arrow predicting satisfaction right here, comma, cove, and we've got severity, asterisk, age, anxiety, asterisk, age. Now make sure there's no space between anxiety, asterisk, and age. Make sure that's all butted up against each other. Now what I'm going to do is, at the end of this, you can see there's more that I want to add. Well, I can create a space and I can add 3 forward slashes and then hit enter, go to the next line. And now I can type in anxiety, asterisk, severity, in parenthesis, then no caps, latent, and then I can type in standardize if I want that. If I wanted to continue on the next line without and just have standardized on that, I can just basically make sure there's a space there and then 3 forward slashes, and I can type in standardize right here. So this right here, if I highlight all of this and hit the execute selection, you can see that there was a little bit of an error because I forgot one thing, which is where it says covariance right here. It says invalid something, unmatched, open parenthesis or bracket. So my mistake, I was getting a little bit too clever there. My mistake is that I forgot to incorporate the, let me see here, find this. Okay, I had to take a second there. What I forgot to do was right here in this main portion where I've got an open bracket, I forgot to put my in parenthesis right there. So make sure that when you're using syntax, make sure that you have everything exactly correct, or else you'll get little error messages like you just saw. So now I'll highlight this and click on execute selection. And so now you can see that I've got my results. So there's the standardized coefficients. Everything is exactly the same as what we had when we ran it using the graphical user interface. Okay, so now let's say that I want to get that equation level goodness of fit. Well, now I could type in ESTAT and then EQGOF, and you'll see that one of the nice things in the current versions of or the current version of Stata is that it gives you sort of recommendations for it's kind of trying to anticipate what you might be trying to request, and you can see that it kind of shows up as ESTAT EQGOF down below. So at any rate, I've typed this in, and if I click on execute selection, then now you can see that we get our equation level goodness of fit. So later on, when we're getting into more complex models, we're not going to only be focusing in on equation level goodness of fit, but we're going to be looking at the overall fit of our more complex models. So if I have a path analysis, or I'm carrying out confirmatory factor analysis, or a path analysis with latent variables, or structural regression analysis, then we're going to also be looking not only at the fit in different components of our model, but we're going to be looking at the overall fit of our model. So that's basically just kind of showing you that right there. So if I highlight file and click on save as, then now you'll see that the option is to save my file as a do file. So just to show you what I'm talking about, Dan, let's go ahead and save this. I'm going to clear this off, and then I'm going to just give this a name. So we'll just call this regression do, or just regression example for short. And I'll click on save. So now this has been saved as regression example. You can see at the top it says regression example. So if I clear this out, and let's just say that so now I've cleared off my my regression analysis. So if I want to open it back up, I can go under File, Open, and you can see there's my do file right there. I'll click on Open right here. It opens up, and then I can basically make changes or run the analysis. We'll just go ahead and rerun everything that I've requested up to this point. So I'll just click on Execute Selection, Do, and there you go. Everything has been run. So it's been batch run, if you will. The other thing too to note in your do file is that you can add comments. There are different ways to do this, but like for instance, if I want to go down here and I want to add in a comment, like if I want to say I'm going to be running a regression analysis, I can type in a 2 forward slashes, and you see that they show up in green. So then I could just say regression analysis example, and then on the next line, then I can type my my syntax in. So I can use the same syntax I'd used before, just to show you using the linear regression example with the regress command. I'll just type in satisfaction, severity, age, and anxiety right there. And let's just say that I want that residuals by predicted plot. I can type in RFV, or say residuals. Yeah. plot right there. So you can see I've typed both of those in, and if I highlight both of these and click on execute selection, you can see that now I've got the plot. So you can see you can batch run whatever your analyses using that do file. So again, I can save this and keep tweaking it or making changes as needed as I'm running my analyses. Now, one last thing that I want to show you is that you can actually perform your structural equation modeling analysis using summary data in Stata. So, for instance, let's say that you're given a covariance matrix and you're not actually given the raw data, but you're given a covariance matrix. Maybe you're given means for your variables or whatever. You can actually run your analysis using that summary data. Now, just keep in mind, though, that you can only do this using structural equation modeling, basically that SEM command that you see right there. So I'll show you kind of how to set this up. So basically, I've already got sort of a document where I've created the covariance matrix for our satisfaction, anxiety, age, and severity variables. So let's just say, for argument's sake, that I'm given the covariance matrix and means for these variables, and I want to run my analysis, run my regression analysis using the SEM command. So to accomplish this, what I'm going to do is, first off, and by the way, you can use asterisk right here if you want to make a separator. That's a lot of times what I will do in my do file. But and by the way, I would encourage you, if you're going to be doing using summary data and typing it in the way that I'm going to show you right here, my recommendation is to use the do file editor in order to accomplish this, because it's way easier than using the command line. So what I'm going to do is I'm going to start off by typing in clear all. So what's going to happen if I type in clear all, then the data set and anything that's currently in memory is going to be basically kind of wiped out. So I'm going to type in clear all, and then just to show you what I'm talking about, if I highlight clear all and then I click on execute selection, you'll see, let me see here. You'll see that I made a bit of an error because it says clear all is not allowed while the SEM builder is open. So I forgot that I still had the SEM builder open. So I need to get rid of this. So I'm just going to get rid of it. By the way, if you wanted to save this, you can just click on save, and then I'll just type in regression and click on save. You'll see that down at the bottom it says SEM path diagram. That's the file type. So I click on save right there, and so it's been saved. So, and by the way, if I wanted to open it back up, I can just go to open, and there's the path diagram right there, and there you go. And then I could actually make edits or run the analysis from that. But I'm going to close that off and go back to my do file. And so now if I highlight clear all, you'll see that now there's no data in my data set. So if I go to the data editor, you'll see there's nothing there, which is fine. That's exactly what we're trying to do. So now that I've cleared that out, now I can actually create essentially a new data set that contains the summary data. So what I'm going to do is I'm going to type in SSD. And so basically this is Stata summary data. So SSD, and then I'm going to type in INIT, basically initiate. And then I'm going to type in the names of my variables, which are age, severity, anxiety, and satisfaction. But I'll just type in SATISF, just keeping it short. You'll also notice that the data set that we were actually using, the variables were actually capitalized in that data set. So that's why we were using caps up here. But for this one, I'm just going to keep it simple, and I'm not, my variables just don't have caps associated with them. So that's the first line. You just type in SSD INIT for initiation, and then the names of my variables: age, severity, anxiety, and satisfaction. Now on the next line, I'm going to type in SSD space set OBS, and then the number of observations, which happens to be 24 in our data set. So we have 24 observations that we have summary data 4, basically. Okay. So next we'll type in SSD. And so I happen to actually have the means for the variable. So I'll go ahead and just show you how to create, how to incorporate the means of the variable. So I'll type in SSD set means, and then I'll type in the values of those, the mean values for age, severity, anxiety, and satisfaction in that order. Make sure that the means are in that order. So I'll type in 40.583 space 51.375 space 2.283 space 60.583. Then I'll go to the next line, and now I'm going to type in the covariance matrix. And just to kind of show you again that we can incorporate comments, let's just say I type in 2 forward slashes, and then we'll just, I'm just going to put typing in covariance matrix. You don't have to do this. This is just showing you that you can add comments along the way. So now I'm going to go to the next line, and I'm going to type in SSD space set space and then COV to indicate that we're talking about a covariance matrix. Now, we could continue this on the same line in the following way. Basically, what we can do is we can start typing in the values for the covariance matrix in the following way. We could type in 91.384, and then we have to type in a forward slash. So I'm going to be typing in the lower triangle for our covariance matrix. So for the age variable, this is the variance for that variable. So I typed in a forward slash, then 30.641, then space 27.288. So that's basically giving me then the covariance between age and severity. That's the 30.641, and the variance for severity, which is 27.288. Then a forward slash, then space, I'm just adding a space here, then 0.584 space 0.641 space 0.100, and then a forward slash right there. So you can see that the slashes are essentially designating the end of a particular entry for a row within the covariance matrix. And like I said, this is the lower triangle for the covariance matrix. Then space, I'll add in negative 122.616 space negative 52.576 space negative 2.399 space 281.210 right there. Now in this case right here, we're not going to add in a forward slash. So now if I so at this point, what I'll do is I'm going to go ahead and highlight all of this, and we'll click on the execute selection do. And so you'll see that we have all our, kind of information about what's been added. If I click on the data file, open data editor, you can see now we've got information. We have our covariance matrix that's given along with the means for our variables. And this is basically containing all our information that we need in order to run our analysis. Now, I'm going to be honest. We'll go ahead and close this out. I'll go back to my do file editor. I generally prefer not to enter it quite in this way right here because it gets really confusing, particularly if you get into much larger covariance matrices that you're working with. So my general preference then would be to kind of enter the lower triangle in a little bit more intuitive fashion. So you can see right here that what I'm going to do is just kind of create that lower triangle. Now, as you're looking at this, what we have is SSD set cov, and then you can see there's the variance for our age variable followed by that forward slash. So we still have to have that forward slash there. Then we have the covariance between age and severity right here, followed by the variance for severity, followed by that forward slash. Then we have the covariance between age and anxiety, between age and severity right here, age and anxiety, and never mind, I'm getting a little bit getting a little bit lost in the details here, but nevertheless, this is basically the covariance matrix right here. And by the way, this also needs to be up here. There we go. That was the error. So now you can see that we've got our covariance matrix for each line. We've got the / ending, except for that last line that you see right here. This is the variance for satisfaction right here. This one right here is our variance for anxiety that we have right here. Then we have the variance for our our severity right there. And then we have our variance for age right there. And then the rest of them are covariances. Now, if you enter in this way, make sure that what you're going to want to do is you want to carry this over from line to line. So what I would do is at the end of this line where we have SSD set covariance, I would add some spaces and then 3 /. Do the same for each line. Okay, so it may look a little bit weird, but it's using the same principle that I was showing you up here, where we had the 3 / in order to kind of wrap things around to the next line. So the reason why I have this set up in this particular way is because it's a little bit easier to enter those covariances in that way than the first way I was kind of showing you. So if we highlight all of this, and I'll go ahead and click clear all again. Actually, I'll go ahead and click clear all just to get rid of everything. And so you can see that looking at the Stata interface, there are no variables and information that's incorporated. If we look at that, the data right here, you can see there's nothing in there. So if I go back to my do file editor right here and I highlight all of this and click on execute selection, now you can see that the variables are included. And then if I go into the data editor right here, we have all that information that we had requested previously. So now we can actually run our analysis using either our drawing program or the syntax that we used above. Just to show you, if I go back, open, and we'll go into we'll open up the SEM path diagram that we drew. So there it is. And if I click on estimation and estimate, you can actually see that I inadvertently failed to remember that our variable names don't have caps in the front of it. So I can actually make the changes right here. So I'll just type in age for that variable, severity for this variable right here. We'll just get rid of the first, we'll just make all these lowercase. Oh, we also have to make sure it's exactly the same as the variables that are in our data set. So the satisfaction variable is now just SATISF. There it is right there. Now, if I click on estimation and estimate, forgot anxiety right there. All right, let's just select. It's probably a little easier to do it that way. There we go. Okay, so now if I click on estimate right here, now you can see our analysis has been run based off of that summary data. And again, the same principle would apply if we were using our previous analyses using our syntax that we had written before. Actually, what I'll do is I'll go ahead and copy this and I'll paste it down here. And let's just get rid of the standardized for this demonstration. Now, remember that because the variable names, because we have caps in the previous syntax, but our variables now don't have caps, we need to get rid of the caps. So I'm going to change our age, severity, anxiety, get rid of the caps for each of these. Oops. All right. So now if I highlight this and run it, you can see that I forgot to also keep in mind that our satisfaction variable is spelled SATISF. So I need to make sure that's fixed. So you can see that if you're not very careful, on certain things, you can end up with little error messages. So I'm going to highlight this now after fixing that. And so now we've got our analysis run again from our summary data. Okay, so that pretty well wraps up this demonstration of how to run our linear regression using Stata.